All right. Can y'all hear me pretty well on my end? All right, y'all. Can y'all hear me on my end? Someone has some nice music playing in the background. That's nice. There we go. All right. Uh, Alrighty, y'all. Can everyone hear me pretty well?
Yep.
All right. I'm guessing that's you, Schuler? All right. So, my goal today is just do problems on power series and just make sure that we know how to solve them, how to find the radius of convergence, and more importantly, how to represent them, a function in terms of a power series. So one result that I'm going to use a lot is this result. If you watch the video lecture notes, you know this result now that I can rewrite the function 1 over 1 minus x as x raised to the k, where the absolute value for x is less than 1. The reason why that's the case is, remember, radius of convergence is 1, and interval for convergence for that guy was -1 to 1. And the reason why I conclude that is because that's how I conclude convergence for a geometric series. And I want to write that formula down because for the problems that we're going to work together with, that is going to be the most common formula that we're using. So with that, here's going to be the question. Find the power series representation for the following functions. And also when y'all find a power series representation, I want y'all to also try to find the radius of convergence. Let's get more room to finish spelling convergence. And the interval of convergence. So here's going to be the first function. So here's going to be the first function that I want y'all to try it on. 5 over 1 minus 4x squared. I want to give y'all a few minutes to try to work that one out, and then we'll work through it together. But keep in mind that when y'all work through that example, try to figure out how can I use this result in the box above to help me out to form that power series representation. I'll give y'all about 3:45 and then we'll go through the problem together. And if y'all have questions about it, post that on the chat or unmute your mic and just ask me questions. I'll be happy to answer them. All right, try to work that one out. And if y'all have questions, let me know. Yeah, sure thing, Anthony. What's up? Oh, you fucking dude. You're in your house. Oh, fucking asshole. I want to say no because of how. Appreciate that, Anthony. See a message and I'll respond to that. See a message. Let's see what that is. Oh, the chat still makes me laugh every now and then. Makes me happy when I read it. So keep working on that problem. So my advice, Unique, to start off, we know the power series representation of 1 over 1 over 1 over 1 minus x is the sum of k equals 0 to infinity of x to the k. And so my question is always start off with, can I rewrite Yates like 1 over 1 minus x? And that's going to be my first step in how to solve that problem and to get that power series. Because I know the power series representation of that function. So I'm going to try my best to relate it as much as I can. And the answer to your question is not related to what you have, because that's our remainder estimate. So that's not going to play a part for this problem. All right, I see a message and I'll respond to you. All right, so give me a status report, y'all. How's this problem going for all of you? All right, I'll ask again because I don't see a response to that question. Give me a status report. How's that problem going for y'all? Good. Okay. about one thing. All right. And so let's start going through the power series and how to find that guy. So our goal is all we know about is that 1 over 1 minus x. Is our thing. Oh, saw a message from Unique. You're really close. It should be 5 times 4 to the kth power, so not 20 times s to the 2k. So you're very close, and we could go through that then. All right, so because the only thing I know of is the power series representation for 1 over x, I want to try my best to relate that as much as I can to that function. So first thing I do, 5 is a constant, so I'm going to treat that as a coefficient and move that on the outside. And Unique sent me this message, and I like his approach. Usually, a lot of people, they'll just leave 4x squared by itself. Well, let's pretend that that's my u, or my new variable x in that case. So in that case, I have 5 equals 1 over 1 minus, and now I substituted in u for the 4x squared. So now I have 1 over 1 minus u, which is now similar to the function 1 over 1 minus x. Because of that, I can now use my power series representation for that. And we now write the sum k goes to 0 to infinity of u to the k. And because it's a geometric series, that's going to be u less than 1 for convergence. I started off with that, so that means I got to finish off with that. So I get 5 times the sum, k goes from 0 to infinity, of 4x squared to the kth power. And I also replace the u with that 4x squared. Now my next step that I'm going to try to do is, I have an exponential here with a product of 2 numbers. So I can rewrite that further to get that is 5 times the series, starting at 0, ending at infinity, of 4 raised to the kth power x raised by the 2k power, absolute value 4x squared less than 1. And there's our power series in a nutshell. And that's why I mentioned, Unique, that you were really close. I think the way that you got 20 was you forgot that that 4 was also being raised to the kth power, and then you multiply 5 times 4 to give you the 20. But besides that, you were good overall. All right, so there's my power series. Now, I have to find my radius and my interval of convergence. So let's find the radius first. So all we know is that this series converges when I'm less than 1. That's all I know so far, because my original series that I played with was a geometric series, and that's for convergence. I'm now going to use the property that says 2 numbers being multiplied in the absolute value is the same as taking the absolute value of each number and then taking their product. And because 4 is already a positive number, the absolute value is redundant. Now I'm going to divide both sides by 4 to give me x squared absolute value less than 1/4. And now my next step is going to be, I need to get rid of that square. Well, I'm now going to use my property again of multiplying two numbers. And I claim that I can move that square outside the absolute value. And the reason why, x squared is just x times x. So I can use my property of absolute values that says absolute value of a product of two numbers is the same as taking the absolute value of each number and then taking their product. So I could rewrite that as absolute value for x times the absolute value for x, or absolute value for x, all of that squared. So I now have absolute value of x squared dividing by 1/4. And then my last action is to take the square root of both sides to give me just absolute value for x. And now I have absolute value for x less than 1/2. Note that I'm not including negative 1/2 in that because absolute value of a number is always positive, it's always non-negative. And so it doesn't make sense for absolute value to be less than negative 1/2, which means our radius of convergence is 1/2. So you're talking about dropping the absolute value? I'm guessing that's what you mean by the, yep. So I can't drop the absolute value yet, mainly because well, I take the square root. I'm taking the square root of the absolute value for that. So I can't drop it yet, and that's mainly because think of it when I take it out of the radical, I don't know if I'm positive or negative. And so that absolute value is staying in there to maintain that I'm remaining positive. So that's why I'm still remaining it in there. That is a good point, though. So I'm glad you brought that up. All right. So now we have our radius of convergence. Now let's find the interval. As I mentioned Wednesday when finding the interval, if I say the absolute value of something is less than a quantity, that is the exact same thing as me saying negative of that quantity is less than x is less than that quantity as well. Or in other words, x is in between the quantity and that quantity with a negative sign up front. And remember, because of this, that's going to form an interval. So that means I know that so far my interval of convergence will be negative 1/2 to positive 1/2, but I don't know if I can or cannot include the endpoints. So now I got to check if I can and cannot include the endpoints for this problem. And the way we check, we plug it into our power series and see if we have a convergence or a divergence series. So I'm now going to plug in, that's an ugly sum, negative 1/2 into our power series. Negative 1/2 to the 2k. Because of that second power, I don't really care about the negative sign because negative sign, square root, the negative sign is going away. I can further rewrite this as follows. I have a product of two powers, so I could rewrite that as taking 1/2 squared and then reminding myself, oh, that's being raised by the kth power. And the reason why I'm doing this is I want to try to simplify my new power, my new series, once I plug in negative 1/2. 1/2 squared is 1/4 raised to the kth power. Means I have 5 times the sum, k equals 0 to infinity, 4 to the kth power, 1/4 to the kth power. So 4 and 1/4 have the same exponent, so that means I can combine them by taking their product and then raising them by the power k. So 5 times the sum, k equals 0, of 4 divided by 4 to the kth power. 4 divided by 4 equals 1. 1 raised by any power is still 1. So I have 5 times the sum, k equals 0 to infinity of 1. And then if you want to be technical, you can move that 5 inside. Say that's the sum, k goes from 0 to infinity of 5. Where it means I'm just adding 5 forever. Now, quick recap. For that series, sum equals k equals 0 to infinity of 5. Is this series convergent or divergent? And also, when you write that on the chat, tell me why you think it's convergent or divergent. All right. So Anthony thinks it's divergent. Why do you think it's divergent? What test did you use? I agree with you with that. So I agree with you, it's divergent. Let's pretend this is the final, and we have to give an actual test for convergence or divergence. What test will we use here? I agree with you that it's divergent, but now be bingo. There we go, Colin. It's divergent by the divergence test. Because in this case, there's my AFK. Limit as k goes to infinity of 5. That's definitely 5. And that's definitely not 0. So that series is going to be divergent by the divergence test. And that's how we can justify it if, say, this was the final and we were asked for a valid, for like a, give us a test for that. It says, surely you probably, I don't know if I said this to you, but I know my students have said this before. The coordinator is very picky. And so just make sure that we get into practice of justifying a result using one of our tests. All right, so that means for the left endpoint, I'm not including it in my interval. Now let's check and see if I plug in the right endpoint, what's going to happen. Well, I say we're going to get the same thing because I'm going to get, right, and I agree with you, Anthony, is that because of that square, just because I plug in 1/2 or plug in -1/2, it's not going to change my work from before. So if I did all the work that I did above in purple, I'll get back that I get the sum of 5, which we know is divergent. Which means in my interval of convergence, I do not include the right endpoint. So that means the final interval of convergence, running out here, now we know everything, is -1/2 to +1/2, open bracket, open parentheses on both sides of that inequality. All right, so if it's going through a problem, do y'all have any questions on data sample and how to use power series in that notation? All right, so for the nets example, I'm actually going to work this one out for y'all because it's going to use a property of combining. No, Anthony, I moved it to Monday. So all the 1080 instructors, we all agreed to move 11.1 to Monday because MyLab Math is sucking right now. All right. And so here's going to be our new function that we repeat the exercise for. X times 2x² plus 1. And so before I start the example, I'm going to tell y'all what property I'm going to be using. And the property that I'll be using is, if I know that this power series, let's say we write the expression, if I know it converges to a function, say f of x already, and m is some power that's positive such that if I have x raised to the n power in front of that power series, then I could do what I expect to do, which is I can factor that x to the n power inside the power series. And because I'm multiplying x to the k and x to the m, since they have the same base, what that's going to be simplified, well, that's an ugly infinity sign. Let's make that a little bit better. C of k, x raised to the k plus m. Then this power series in star converges to x to the n power times f of x. So essentially what that property is telling us, if I'm multiplying a function by, say, a power of something else, then what this property is telling us is where it's valid for us to do what we want to do, which is we write the function f of x as a power series, and with that x to the m, we could just factor in inside our power series as we would expect. And so let's see how we do that with that g of x over there. Oh, there we go. So I'll rewrite g of x so I don't have to scroll back up. So again, I'm going to try to relate this with the power series 1 over 1 minus x equals the sum k equals 0 x to the k, where absolute value for x is less than 1. Right now I have a denominator of 2s squared plus 1, which looks strikingly similar to 1 minus x because I could rewrite my denominator as 1 minus negative 2x squared. So if I see a plus in that denominator, I'm switching it over to a minus by doing minus and negative. And the next thing I'm noting is I have that coefficient x that I don't know a power series representation for. So I'm going to move that up to the front and work with 1 over 1 minus negative 2x squared for that. And now I know how to deal with this guy. I'm now in the same form as 1 over 1 minus x. The only difference now is wherever I saw x originally, I'm going to replace with negative 2x squared. So that means I now have x times the power series k starting at 0 to infinity of negative 2x squared to the kth power. Let's go ahead and try to simplify our power series first. I have a couple things being multiplied, and it's all being raised by the same power k. So I'm going to use my property of power series that tells me product of a couple of numbers raised by the same power is the exact same as raising each of those terms to the kth power and then multiplying them. So I have x times the power series k equals 0 to infinity. Because I have that negative sign up in front raised to the kth power, I have a negative 1 to the kth power that I'm technically in there. Because negative 1 is one of the terms that's in my product. Next, I have 2 to the kth power. And then I have x squared to the kth power, which we can rewrite as x to the 2k. Now I'm going to use my property that was mentioned above that says if I have x raised by a power on the outside, I can move that inside my power series and then combine them, which will give me the power series. Let's try to write that again. K goes from 0 to infinity of negative 1 to the kth power times 2 to the kth power times x, but now raised to 2k plus 1. Because we used the formula for geometric series for convergence, I technically need here the absolute value of negative 2x squared is less than 1 to verify and to validate that claim. So there's my brand new power series. Let's go ahead and figure out what our radius and interval of convergence is. So first, radius of convergence. I know yes off the bat because I used my formula for the power series of 1 over 1 minus x. Because I'm inside an absolute value and I have a negative sign, that negative sign is going to go away. So I'm now left with absolute value of 2x squared less than 1. And now I can repeat the same work that I did in the previous problem, where now is x absolute value mu to square on the outside less than 1/2. And then I take the square root of both sides, and I get the absolute value for x is less than 1 over square root of 2. Or, if you really want to, you could rewrite that as root 2 over 2. It doesn't matter which form you put that in. I just think it's pretty epic to see root 2 over 2. So I'm going to leave it as root 2 over 2. All right, so now we have our radius of convergence. Now we have to find our interval of convergence. So because we have x is less than root 2 over 2, that is the exact same thing as me writing negative root 2 over 2 less than x less than root 2 over 2. So that means our guess for interval convergence is negative root 2 over 2, positive root 2 over 2. And now we have to check and see if we can include our endpoints. Let's try negative root 2 over 2. Let's see what happens if we get that. So our power series, k goes from 0 to infinity, negative 1 to the kth power. You have 2 to the kth power. And another reason why I want to rewrite it as root 2 over 2 is I do want to use that to my advantage when I'm trying to simplify. So let's try to simplify that nasty guy. All right. So first thing I'm going to do, because it is 2k plus 1, I'm going to go ahead and separate that plus 1 power by doing the following. Rewriting that as 2 to the kth power, and then also having an extra negative root 2 over 2. Because I have an extra negative sign, I can essentially say that negative 1 goes with this negative 1k to rewrite that as negative 1 to the k plus 1 power. And also for that negative sign, because the power is even, negative sign and the even power, the negative sign's going away. So I get the sum k goes from 0 to infinity of negative 1k plus 1, 2 to the kth power, and then root 2 over 2 to the 2k power times another root 2 over 2. Well, not necessarily, Schiller, because if I plug in positive root 2 over 2, it'll be 1 to the kth power. But it's going to be similar with what I'll be doing. So I'm glad you caught that earlier. So not the same, but similar. All right. So I'm going to do some rewriting, and it's mainly going to be rewriting of that root 2 over 2 to the 2k power. So with the numerator, I have 2 square root of 2, or 2 to the 1/2 raised to the 2k power, and then 2 to the 2k power. Good Lord, I can't read today. I forget into 2k power. Oh, and I did it again. Okay. All right, so because of that 1/2, it's going to cancel that 2 in the exponent. So I'm just left with 2 to the kth power over 2 times 2 to the kth power. And I can simplify that even more because I have a quotient of two numbers with the same base. So that's going to be the difference of the, go away. So that's going to be the difference of the exponents. K, 2k, I have negative k, and the highest one was in the denominator. So, there we go. 1 over 2 to the kth power. So I can now substitute in root 2 over 2 to the 2k power as 1 over 2 to the kth power to give me the lovely guy sum k goes from 0 to infinity of negative 1 to the k plus 1 power, 2 to the kth power, 1 over 2 to the kth power, times a root 2 over 2. That's there. Those two get to kill each other off, and now I'm just left with k goes from 0 to infinity, and negative 1, k plus 1, root 2 over 2, or root 2 over 2 times the sum going from 0 to infinity of negative 1 to the k plus 1 power. And now for this series, do y'all think it's going to be convergent or divergent? And when you do that, tell me a test of what you would use to explain why. Okay. So Anthony, when you say alternating, you're thinking of alternating series tests, or are you talking about, can you be more specific what you mean? And also unique. Okay. So Anthony, I actually would not agree with the alternating series test, mainly because my b of k here will now be 1, which means that will not satisfy the non-increasing portion because 1 is definitely not changing, so it's not getting smaller. And the limit of that is 1 and not that. Actually, Unika, I agree with you earlier about the alternating part. So I claim it diverges. And it diverges by divergence test. And let's explain why that diverges by the divergence test. So I have limit as k goes to infinity of a of k. In my terms in the series is negative 1 raised to the k plus 1 power. And now this guy, this is going between positive and negative terms, but is not shrinking. So I claim that this limit does not exist. And the reason why it's not assisting is because it's going back and forth between a +1, -1, and it's not shrinking at all, so it's not leveling out. So it's oscillating. Bingo. And not only that, oscillating without shrinking. Because remember our result before, where I could have a -1 to the kth power that still converges or gives us a limit, where we use the property if this limit equals 0, then the limit of that sequence goes to 0. So it does not assist any, mainly because it's oscillating, and the distance between the x-axis is not shrinking. Because I'm always a distance of 1 away from that. So that's the main key part here, is that my sequence, the -1 to k plus 1, I'm not getting smaller or smaller every time I'm oscillating. It's still a fixed distance of 1 from the x-axis. So that's the main reason why it does not assist. Oscillating with no shrinkage in the distance to the x-axis. And that's the main idea. And I sure as heck know that does not assist is definitely not 0. So divergence test tells me the yes series is going to diverge. Correct. If it doesn't change distance from the main axis, then that's going to be a does not assist limit, because I'm always fixed, but I'm bouncing back and forth between a positive and negative number, which means I'm not leveling out anywhere. So you're exactly right, Unique. All right. And back to Anthony's comment of they'll be the same again. It's going to, Isaac. And that's why I'm bringing back Anthony's comment of they're the same again. Because if you plug in positive root 2 over 2, yeah, you'll get the series. I actually forgot the series. There we go. So -1k, 2 to the kth power, but you'll just have -2 to the 2, root 2 over 2 to the 2k plus 1. And if you do all this work, and I'll go ahead and do ... and say that math occurred. Because it's the exact same steps as our work above here. It's just we don't have k plus 1 anymore. So I'm just going to say we did some math, and we got that to be equal to, let's change that to orange. Sum k goes to 0 to -1 to the kth power. And this will also diverge by the divergence test. So that means our final interval of convergence is -√2 over 2 to √2 over 2, open parentheses throughout. See something? I'll check. So Isaac, your pun game is on point today. That's actually really funny. I have an office mate who he does a lot of puns. y'all know him as Schuler. You definitely know him. For everyone else, he's the big guy who comes into my classroom all the time. Sweetie Petey, that's right, cute Peter. He is an interesting person. That is the best way I can describe that man. But yeah, cute Peter. I don't know if I would call her cute, but I'm glad someone does. All right, but back on topic. Any questions on data sample before I'll try another problem?
Yeah, I have a question.
Yeah, go for it, Isaac.
All right. So if you are on the last step, right,
Mm-hmm.
and you're looking for tests, is 9 out of 10 times, is this going to be just like a divergence test?
Mm. So I wouldn't put that correlation there. The reason why I tried divergence tests is my
Hmm.
idea for divergence tests is when in doubt, if I don't see what test to use, I'll try divergence
Okay.
test. So I wouldn't do that correlation. Um, I would do the correlation in the sense when I'm checking for convergence or divergence, when I plug in the endpoints of my interval of convergence, I ask myself, kind of following the guidelines of picking a test, um, which test should I use here? In this case, I use divergence because I saw that the terms inside the series, it does not go to zero. So that's
Hmm.
why I chose that very quickly. There might be a case where, let's change this up. Let's say I had to decay power in there.
Hmm.
Then I would choose alternating series tests to show convergence.
Oh, I see. So we're gonna have to think around those sort of tests here.
Bingo. Or if I
Okay.
had factorial, because I have the factorial, I would use ratio tests because that helps me to get rid of that factorial. So
Gotcha.
that's what I would think of.
Okay. Well, that answers my question.
Alrighty. That's a good point to note because with power series and picking the interval and radius, this is now testing all the series tests that we've done before. All right. Any other questions that y'all have? If not, then I'll pick another problem. Let's see what will be a good one. Ooh, that won't be mean. Okay. So let's now say our h of x is the following. 2x squared minus x minus 1. And so what I want y'all to try to do is to try to make a paraseries representation of that and find the radius of convergence and find the interval of convergence. But for that, I'll give y'all a hint for that. My hint is to use PFD. The reason why I say that is I want to rewrite it into the form something similar to 1 over 1 minus x. And with a denominator of 2x squared minus x minus 1, I can't really see it in that form. But I claim that we can try it with a partial fraction decomposition. So when y'all try that, my hint is to use PFD in order to get that guy. So I'll give y'all about 10 minutes to work on that. If y'all have questions on that problem, let me know, either via the chat or unmute your mic and ask me the question. While y'all do that, I'll take a sip of water, which is the proud sponsor for ESSU meeting. I'll be right back. One of my roommates has a question for me, and I'm going to answer his question. So unique in this case, we're not taking the integral. We're just doing partial fraction decomp to separate h of x as two things that look similar to 1 over 1 minus x. That's our goal. So we're not taking an integral here. So let's look at chat. See a message in the chat. All right, so since it's close to 5, let's go ahead and go over the solution. We are now experts at partial fraction decomposition thanks to Unit 2. What did y'all get as your function after partial fraction decomposition? All right, there's Colin's answer. How about everyone else? Did y'all get something similar to Colin, or did y'all get something different? All right. Well, I say you didn't give Colin, because that was what I got when I did PFD. 1 over x minus 1 minus 1 over 2x plus 1. So I agree with your answer for that. Does anyone want me to go over to PFD and how we got 1 over 1 minus 1 minus 1 over 2x plus 1? Sure, faster. All right. So in that case, let's put a y. Let's see how fast this will be. 2x squared minus x minus 1. If you factor out the denominator, you get 2x plus 1 times x minus 1, which means a over 2x plus 1, because they're both linear, plus b x minus 1, which means after combining you get a times x minus 1 plus b 2x plus 1 over 2x plus 1 times 2 times the x minus 1. All right, and now we set the s plus 2 equal to the a x minus 1 plus b 2x plus 1. I'm going to use method 1, which means I'm just going to pick one makes it 0. I'm going to plug in 1 because I know that makes the a part 0. And so I'll have 1 plus 2, which gives me 3 on the left-hand side, equals 2 b. Let's see. Yeah, that's fine. Plug in 1, so 3. Divided by 3, I get 1 equals b. And then 2x plus 1, that becomes 0 when I plug in negative 1/2. When I plug in negative 1/2, I get 4 halves over minus 1/2, so 3 halves equals 2 a times negative 3 halves, which means a is negative 1. And boom goes to dynamite, because now we're done. So yay, we got it. We got our partial fraction decomp. Now let's see how we can use that for that going. All right. So now we have h of x equal to 1 over x minus 1 minus 1 over 2x plus 1. And now I want to get into the form of 1 over 1 minus x. To do that, I'm going to do the reordering here. They give me 1 over, and I'm going to factor out a negative sign. And the reason why I'm factoring out negative is so I can rewrite 1 over x. Negative 1 over x minus 1 over 2x plus 1. Well, that negative sign, that's just a coefficient up front. So I'll just move that up to the front. And my other rewriting that I'm going to do is with this denominator. I can rewrite that as, move that 1 up front because I have 1 plus 2x. I could do 1 minus negative 2x. So now I get to use my power series representation, negative. Well, this is our normal power series from before. Sum k goes to 0 of x to the k minus the sum k goes from 0 to infinity of negative 2x to the kth power. And one thing I'm going to note is this series is convergent when x is less than 1. And this series is convergent when the absolute value of negative 2x is less than 1, or 2x is less than 1. And I'm going to use that through, and I'm going to keep that as a note. But because I have two separate power series, I can combine them by adding and subtracting. But one thing that I'm actually going to do is I have a negative sign and a minus. So I'm actually going to factor out that negative sign to give me x to the k plus some k goes from 0 to infinity of negative 2x to the kth power. And I'm going to go ahead and rewrite that as negative 1 to the kth power times 2 to the kth power times x to the kth power. Close my parentheses. All right, so now I have two series that are just being added together. I can combine two series by adding both the terms together, which gives me the sum k goes from 0 to infinity of x to the k plus negative 1 to the kth power, 2 to the kth power times x to the kth power. And inside that series, I see that I have a common factor of x to the kth. So I can technically factor that out within my series to give me, for my final power series representation, the sum k goes from 0 to infinity of 1 plus negative 1 to the kth power times 2 to the kth power times x to the kth power at the very end. And there's my lovely power series representation for that guy. All right. So before we go and talk about the radius and interval of convergence, any questions so far? All right, post your questions on the chat. And I'm going to go ahead and say that finding the radius of convergence is a little tricky. And the reason why is because we have two different series that converge at two separate rates. So from the first series would converge when x is less than 1. And the second series converge when the absolute value for x is less than 1/2. And so now it's like what to choose for the radius, what to choose for the interval. And here's kind of going to be my rule of thumb if this happens. And I'll try to make this a little bit more clear with a photo. So there's 1 to -1. There's -1/2 to +1/2. Because I centered at 0, I'll put 0 there. And in essence, Anthony, that's going to be my game plan. So if I have two separate intervals that could be possible, I'm going to choose the smaller one. And the reason why I'm choosing the smaller one instead of the larger radius of convergence is because I'm combining two power series into one. I want to guarantee that both series are convergent. And the way that I can guarantee that both series are convergent is if I choose the smaller radius of convergence. Because if I have absolute value for x is less than 1, and the fact that it's less than 1/2, then I have yes inequality. And so my rule of thumb if I'm adding and subtracting two power series and I have to choose the radius of convergence, I want both of those power series to converge. And to ensure that both of those power series converge when I add or subtract, I'm going to choose the smaller radius of convergence. So when adding or subtracting two power series with different and I'll use radii for the plural, radii of convergence. Choose the smaller one. And that's because that's going to guarantee us that we have convergence for both of those power series when I add or subtract. So for this problem, my radius of convergence is going to be 1/2. Does that make sense to everyone why I chose 1/2? Because I think this is one where it's not explicitly mentioned in either my notes or like anything else. So I want to make sure that we're on the same page with that. All right, good. Good. All right, and now the interval of convergence. Oh, interval of convergence, as we talked about, centered at 0, less than 1/2, so -1/2 and half. Correct. That's essentially it, unique. All right, and now let's check if we have convergence or endpoints. So now we're going to plug in -1/2 wherever I saw a 0. So 1 plus -1 to the kth power times 2 to the kth power times half to the kth power is equal to negative infinity k equals 0, -1 plus -1 to the kth power, 2 to the kth power, and because I have a -1 to the kth power times 1/2 to the kth power. So essentially now two things that are being distributed to both of them. And let's see what's going on. So with that -1, that's going to change that to a -1, k plus 1 power, and then just 1 over 2k plus. So I have -1 to the k originally, and then another -1 to the kth power originally. So that -1 to the kth times the -1 to the kth gives me -1 to the 2k power. And then I'll have a 2 over 2 to the k power as well. Because this power is even, that's just going to be 1. Because 2 divided by 2 gives me 1, that's will also be 1. So now I have negative sum k goes from 1 to infinity of -1 to the k, that needs to be zeros, to the k plus 1 over 1 to the 2k plus 1. And now we got to show convergence or divergence for a series. Well, to show that, I'm actually going to split that up to make it more clear what's happening. And here I'm now going to show convergence or divergence for all of them. Since it is 5, I'm going to give kind of the gist of what's going on. So for the first series, -1 to the k plus 1 over 1 over 2k, is it convergent or divergent? And which test? Unique says alternating series. Yep. And yep. So the first series converge. What about the second series? The sum going from k equals 0 to 1 of just adding 1. Divergent, right. By which test? Bingo. Because my a of k is 1, 1 is definitely not equal to 0. And so now I have a convergent series added with a divergent series. So unique, you are exactly correct. Yes, overall will be divergent. Because if you add a convergent with something that blows up, that makes the whole thing divergent. Which means I do not include -1/2 here. And go ahead and mention it again, Anthony. If you plug in 1/2 in here, you're essentially going to get the exact same result. It's just 1 over 2 to the kth power. And then just -1 to the kth power here. So I'll go ahead and write down the series what the series will look like after I simplified. You should get something similar to Yets once you simplified. Well, not same in the sense that because we have to do different tests for the first guy, but the same principle is happening. Let's get into practice of things. Thanks for principles. All right, first series. That's a geometric series with r less than 1, so that's going to converge. And we already talked about the second guy. That's going to diverge, which means the whole thing will diverge. Therefore, our interval of convergence is -1/2 to +1/2, not including the endpoints. All right. Any questions on this problem in particular, or anything about our course in general before we wrap things up, since it's around 5?
Okay, that was some spicy math, but I do have a question.
Go for it.
Okay, so going back to the principle of convergence and divergence and how
Mhm.
just like the whole thing diverges if one does, that's cool and all. But when rewriting the actual expression, when we solve for x equals -1/2,
Okay.
and I kind of want to look back over that just for a second.
Yeah, go for it. Tell me where to
If I had
look
questions
for.
to ask, I would definitely ask them.
No, go for it. We did a lot of stuff here.
Yeah. Okay, so it's basically distributing, knowing your power rules,
Mhm.
and then putting them into functions that you know will be able to solve by a series test.
Bingo.
Okay.
Yeah, my whole goal for all of this nasty scratch work is, can I simplify it in a nice form to make my overall work easier at the end?
Mhm.
And that's the only time when I would like to simplify is it going to help me at the very end? If it's simplifying like your final answer, I don't really care, because at that point, simplifying will be for chumps.
True. Simplifying is definitely for chumps.
but in this case, I would actually simplify it so that way, because I'll tell you right now, Isaac, I do not want to try a series test
Mhm.
and the expression before I distributed the -1 to the kth power, 1/2 to the kth power, because that I don't recognize. I don't know how to do that yet.
Okay, that makes sense.
So I would try to simplify further until I get to a point where I can use the series test that I know.
Right, that makes sense. Okay, that's all the questions I had.
Alrighty. Any other questions from anyone else in the audience?
Also,
No,
we're
yeah.
in class. We have like 30 people.
Say what?
Didn't we have like 30 people to start in Calc 2? Like, what happened here?
Oh, well, you see, since this is online, you talk about with the online meetings, Isaac. Well,
Yeah.
they're always. Well, I'm not taking track of attendance, and this is mainly for Q&A, just for helping. So
Yeah.
I've had students email me saying, "Is this required?" And I'm like, I mean, I don't know how it can enforce attendance. So that's why, if you have questions, show up. If not, then all right. Try to contact me in however way you can. Which is why on average I get, I think, 10 people or so. Oh yeah, they're just watching the videos unique. Like, that's fine. And that's why I structured. I'm thinking of structuring the Zoom meetings like the way I'm doing now, because I think it's kind of because what's the point of watching the videos if I just do the lecture again during the Zoom meeting? I'd rather focus the Zoom meeting on solving problems.
Yep, definitely makes sense. Alrighty, well, that's all the time I have for today. Everybody, I hope you have a great one.
All right. See y'all. Have a nice